There's this force all around us, silent, invisible, but it's literally the engine that moves our modern world. So today, we're going to pull back the curtain on one of the most important inventions ever, the electric motor. You've probably heard that famous quote from Arthur C. Clarke, right? Any sufficiently advanced technology is indistinguishable from magic. And honestly, when you think about it, an electric motor feels kind of like magic. I mean, you put electricity in one end, and out the other comes this powerful, silent motion. It's the secret force inside, well, everything, from your toothbrush to a high-speed train.
So, what is the trick? Well, it's not magic, it's physics. The real question is, how do we take this invisible electrical energy and turn it into the force that actually moves our world? Let's find out.
All right, first things first. The secret here isn't about gears or combustion like you might think. Nope, it's a fundamental force of the universe, an invisible power that, once we figured it out, we learned how to harness and control.
Okay, so what is an electric motor really? At its heart, it does one simple job. It takes electrical power and turns it into mechanical power, motion. It's pretty much the exact opposite of a generator, which does the reverse, takes motion and makes electricity.
And here's where it gets cool. This picture literally makes the invisible visible. See, the entire idea of an electric motor is built on magnetism. These beautiful lines of force you're seeing, thanks to these iron filings, that's what we're going to play with. That's what we're going to use to create spin.
And the rule that makes it all work? It's super simple. You learned it in school. Opposite poles attract, and poles that are the same, they repel. That's it. This constant invisible dance of push and pull, that's the engine we're building. It's the force that creates what we call torque, which is just a fancy word for the rotational power that makes the thing spin.
Okay, but there's a problem, right? A regular magnet is just always on. To build a motor, we need to be able to control this force. We need to turn it on, turn it off, and even flip its poles whenever we want. So how do we build a magnet we can actually control?
Well, it turns out that any single wire with electricity running through it has a tiny little magnetic field around it. Barely anything. But here's the trick, the real aha moment that made motors possible. You coil the wire. By wrapping it up, you focus all those little fields, and you turn this tiny whisper of a force into a seriously powerful, controllable electromagnet. And it's simple. More coils equals more power. This right here is the key that unlocks everything.
Okay, so now we have our parts. We can start building. First, you've got the stator. That's the stationary part on the outside that holds the big magnets. And then, inside that, you have the rotor. That's the part that's actually going to spin. And we're going to turn this rotor into our very own powerful electromagnet using those coils of wire we just talked about.
So we've got our stator with its north and south poles, and a rotor we can turn into an electromagnet. Sounds easy, right? Just get them to push and pull each other. But this is where things get tricky and where the real genius of the motor comes into play. See, getting one good push is easy, but getting it to spin over and over and over again, that's the hard part. Let me walk you through the problem. So, first, we turn on the power to the rotor coil. Its north pole gets repelled by the stator's north pole and bam! It starts to spin. Awesome. But wait. After just half a turn, the rotor's north pole is now right next to the stator's south pole. And what do opposites do? They attract. And it just gets stuck. The forces are perfectly balanced, and the whole thing grinds to a halt. So, what do? How do you keep it spinning? This was the huge problem that early inventors were trying to solve. How on earth do you flip that attraction back into repulsion at the exact right moment to keep it going?
The answer is a piece of absolute mechanical genius called the commutator. Just think of it like an automatic reverse switch. It's this clever little split ring connected to the rotor, and every single time the rotor does a half turn, the little brushes that supply the power cross that gap in the ring. What does that do? It instantly reverses the flow of electricity. This flips the rotor's magnetic poles, so the side that was just being attracted is now suddenly being repelled, giving it another powerful kick. It is such a simple, elegant solution to a really tough problem.
So that clever little device, the commutator, that's really the heart of what we call a direct current or DC motor. But that's not the whole story. There's a whole other family of motors out there, and they're built for a totally different kind of electricity, alternating current or AC. The stuff that comes out of the outlets in your house.
So what's the difference? It's all about the strategy. With a DC motor, remember, we use that mechanical switch, the commutator, to flip the magnetic field of the part that spins, the rotor. But with an AC motor, the design is, well, it's even more clever.
It uses the electricity itself, the fact that it's alternating, to create a magnetic field in the stator, the stationary part, that is already spinning on its own. I want you to imagine something. Instead of one current, you've got 3 separate currents, all flowing in perfect rhythm, but each one hitting its peak at a slightly different time. Now, if you feed those into coils that are arranged in a circle in the stator, you don't just get a simple push and pull. You create a magnetic field that smoothly and naturally rotates all by itself. So the rotor in the middle, it can be just a simple magnet, and it just gets dragged along for the ride, constantly chasing this spinning field. It really is like a magnetic carrot on a stick. There are no brushes, no commutator. It's just beautiful, elegant physics.
Okay, so we've got these 2 amazing ways to create rotation. Now, let's zoom out a bit and look at what we've actually done with this technology. Because honestly, these little devices are the invisible workhorses of our entire world.
I mean, just look at the sheer scale of it. On one hand, you've got these massive motors driving huge pumps in a water treatment plant. And on the other, you have these teeny tiny, super precise motors that keep a drone perfectly stable in the air. Big or small, the basic idea is exactly the same. They are absolutely everywhere. In our homes, our cars, our factories, they are the hidden force behind pretty much everything.
But of course, the story doesn't stop there. We're always pushing for things to be better, right? We want more performance, higher efficiency, and for them to last longer. And that drive is constantly pushing motor technology into the future. Let's go back to that commutator in the DC motor for a second. That mechanical switch with the brushes physically rubbing against the ring, it's clever, for sure, but it's not perfect. It creates friction, which wastes energy as heat. Those brushes wear out, and you have to replace them. For really high-performance stuff, we knew we had to find a better way.
And that brings us to the brushless DC motor, the next big step in the evolution. Instead of a clunky physical switch, it uses a smart digital solution. You've got these tiny sensors that know exactly where the rotor is at all times, and super fast electronic switches, transistors, that reverse the current at the perfect microsecond. And because there's no friction from brushes, they're way more efficient, they're quieter, and they last practically forever. This was the leap from a mechanical world to an electronic one.
And this innovation, this is what's making our electrified future possible. Think about it. The insane performance you get from an electric car, the incredible precision of a robot arm, the reliability of a giant wind turbine, or the agility of a drone. All of that is powered by us getting better and better at mastering this force of electromagnetism.
So, the next time you see something move, and there's no noisy engine, no exhaust, just remember that invisible magic that's at play. Learning how to master motion using the fundamental force of magnetism, well, that didn't just power the last century. It is the very foundation we are using to build the world of tomorrow.